Mobile phones, especially smartphones, the demand for the Android operating system has reached a binametraya. Android phones are now behind finite various altitudes. But there is no end-user demand. The new processor Qualcomm Snapdragon mobile chip manufacturers sees fair announced to 835. 7 new facility includes 835 processor. Qualcomm said the details. 1. Advanced VR, virtual reality in the future will be mobile phone, VR. Technology is easy to use medium. However, there are still some serious errata. But luckily the 835 chip containing 5% faster graphics rendering comprehensive mobile VR will improve picture and sound quality. 2. Advanced photo and video, Snapdragon 835 chip will bring many changes in the mobile phone photos and videos. As a result of the use of these chips will be faster autofocus camera, and the image will be stability. 3. 2 cameras. In the last year or two, dual cameras showed iPhone 7 Plus, the LG G5, Huawei P9. The 835 chip is a result of the use of the camera lens can be used together easily. 4. Battery life, a demand all Android phone users so that the battery is long-lasting. Qualcomm will ensure the perpetuation of the chip on the battery charge after 5 minutes or 5 hours to charge their battery. 5. Improved security, the protection of user data using various biometric sensor chip. 835 Nirapattabia-based Hack phones will be developed. 6. High-speed internet connection, 835 by 16 gigabit class chip is an integrated LTE modem support, which will be able to speed up to 600 Mbps. This will lead to a 5G network. 7 on HDR, high dynamic range, 835 genres of video that will support mobile phone chips. Pre-release edit. Qualcomm announced it was developing the Scorpion Central Processing Unit, CPU, in November 2005. 2.3. The Snapdragon System on Chip, SoC, was announced in November 2006 and included the Scorpion processor, as well as other semiconductors. 3.4. This also included Qualcomm's first custom hexagon digital signal processor, DSP. 5. According to a Qualcomm spokesperson, it was named Snapdragon because Snap and Dragon sounded fast and fierce. 6. The following month, Qualcomm acquired Ergo Networks for an undisclosed amount, it said. Ergo's 802.11a/b/g and 802.11n Wi-Fi technology would be integrated with the Snapdragon product suite. 7.8. Early versions of Scorpion had a processor core design similar to the Cortex-A8. 3. Early Snapdragon products edit. The first Snapdragon shipments were of the QSD 8250 in November 2007. 9. According to CNET, Snapdragon's claim to fame was having the first 1 GHz mobile phone processor. 9.10. Most smartphones at the time were using 500 MHz processors. 9. The first generation of Snapdragon products supported a 720p resolution, 3D graphics and a 12-megapixel camera. 9/11. By November 2008, 15 device manufacturers decided to embed Snapdragon semiconductors in their consumer electronics products. 12/13. In November 2008, Qualcomm announced it would also compete against Intel in the netbook processor market with dual-core Snapdragon system on chips planned for late 2009. 14. It demonstrated a Snapdragon processor that consumed less power than Intel chips announced around the same time and claimed it would also cost less when released. 16/17, that same month, Qualcomm introduced a Snapdragon-based prototype netbook called Kayak that used 1.5 GHz processors and was intended for developing markets. 13/14/18. In May 2009, Java SE was ported and optimized for Snapdragon 19. At the November 2009 Computex Taipei show, Qualcomm announced the QSD8650A addition to the Snapdragon product suite, which was based on 45 nanometer manufacturing processes. It featured a 1.2 GHz processor and had lower power consumption than prior models. 2021. Adoption edit. By late 2009, smartphone manufacturers announced they would be using Snapdragon semiconductors in the Acer liquid metal, HTC HD2, Toshiba TG01 and the Sony Ericsson Xperia X10. 10/22/23, Lenovo announced the first netbook product using Snapdragon SoCs that December 24. According to PC World, mobile devices using Snapdragon had better battery life and were smaller in size than those using other SoCs. 25. By June 2010, Snapdragon chips were embedded in 20 available consumer devices and incorporated into 120 product designs in development. 26. Apple had a dominant market position for smartphones at the time and did not incorporate Snapdragon into any of its products. The success of Snapdragon therefore relied on competing Android phones, such as Google's Nexus 1 and the HTC Incredible, challenging Apple's market position. 26. Android devices did end up taking market share from their iPhone and predominantly used Snapdragon. 27/28/29, as of July 2014. The market share of Android phones had grown to 84.6%. 30. There was an unconfirmed but widely circulated report speculating that Apple was going to start using Snapdragon SoCs in Verizon-based iPhones. 27. As of 2012, Apple was still using their own semiconductor designs. 31. Support for the Windows Phone 7 operating systems was added to Snapdragon in October 2010. 28. By 2011 Snapdragon was embedded in Hewlett-Packard's WebOS devices 32, and had a 50% market share of a $7.9 billion smartphone processor market. 33. By 2015, Snapdragon was used in most non-Apple smartphones. 34/35. Snapdragon chips are also used in most Android-based smartwatches. 36. Snapdragon products have also been used in virtual reality products, in vehicles like the Maserati Quattroporte and Cadillac XTS and in other applications. 37. Later models edit. Snapdragon S4 processor, Qualcomm MSM 8225. In June 2010, Qualcomm began sampling the third generation of Snapdragon products, two dual-core 1.2 GHz system-on-chips, SoC, called the Mobile Station Modem, MSM, 8260 and 8660. 38. The 8260 was for GSM, UMTS and HSPA Plus networks, while the 8660 was for CDMA 2000 and eVideo networks. 39. That November Qualcomm announced the MSM 8960 4041, 4 LTE networks. 39. In early 2011, Qualcomm announced a new processor architecture called Crate 42, which used the ARM v7 instruction set, but was based on Qualcomm's own processor design. The processors were called S4 and had a feature named asynchronous symmetrical multiprocessing, ASMP, meaning each processor core adjusted its clock speed and voltage based on the device's activity in order to optimize battery usage. 43. Prior models were renamed to S1, S2 and S3 to distinguish each generation. 44. The S4-based generation of Snapdragon SoCs began shipping to product manufacturers with the MSM 8960 in February 2012. 45. In benchmark tests by AnonTech, the MSM 8960 had better performance than any other processor tested. In an overall system benchmark, the 8960 obtained a score of 907, compared to 528 and 658 for the Galaxy Nexus and HTC Resound respectively. 46. In a quadrant benchmark test, which assesses raw processing power, a dual-core Crate processor had a score of 4952, whereas the quad-core Tegra 3 was just under 4000. 47. The quad-core version, APQ 8064, was made available in July 2012. It was the first Snapdragon SoC to use Qualcomm's Adreno 320 graphics processing unit GPU. 48. Recent developments adoption of Snapdragon contributed to Qualcomm's transition from a wireless modem company to one that also produces a wider range of hardware and software for mobile devices. 49. In July 2011, Qualcomm acquired certain assets from Gesture Tech in order to incorporate its gesture recognition intellectual property into Snapdragon SoCs. 50. In mid-2012, Qualcomm announced the Snapdragon Software Development Kit (SDK) for Android devices at the Uplink Developer Conference. 51. The SDK includes tools for facial recognition, gesture recognition, noise cancellation and audio recording. 51. That November, Qualcomm acquired some assets from EPOS development in order to integrate its stylus and gesture recognition technology into Snapdragon products. 52. It also collaborated with Microsoft to optimize Windows Phone 8 for Snapdragon semiconductors. 53. Qualcomm unveiled its next-gen Snapdragon 835 flagship SoC on November 17, 2016, which will be built by Samsung using its 10nm FinFET process. The new processor will have 30% more parts within their same space and will have 27% better performance with 40% less power.